The lecture is being recorded from now onwards, just for your information purposes. Right, uh, what you see on your screen currently, that's the tutorial that I went through in the last lecture that we had. And I went through it in quite a bit of detail, explained to you how we actually select the pipe size for sewer reticulation, how we calculate the peak flow in the pipe, and the design, how we actually choose a particular pipe for that. Right? So you can watch the video if you missed it, and that's there. To finish off this section, I want to go through and explain to you about the details, the manhole details and pipe details that we need in a sewer reticulation network. And next week, I'll move on to stormwater reticulation, and then thereafter, there's still a few more small topics that we need to discuss in terms of flexible pipes and rigid pipes and things like that. So we're approaching towards the end of this particular module. Right. Now, what you see on the screen now, this is a typical drawing from eThekwini municipality. It's their standard drawing of manhole details. Now, you may be wondering, but what has this got to do with sewer reticulation design? It's just a drawing file. What I'm using it for is to explain to you certain aspects of the design where we have pipe intersections and how do we detail those pipe intersections. So just to give you an overview of what I'm going to go through in this lecture, so that you'll see the whole story will come together. Um, when it comes, we know that in a sewer reticulation pipe, we have laterals and collector pipes. So it means that certain pipelines are going to join into other pipelines. And it's the way that these pipelines join into each other that's where we need what we refer to as manhole details. So it's that actual connection between different pipelines in a sewer reticulation network. At every intersection or at every join in a pipeline, we put manholes over there. And I'll explain to you the significance of these manholes and how in a short while. Then what you're seeing now on the screen, this is a portion of a much larger drawing. This is the plan layout drawing. Uh, this is where we provide information, or it shows the overall layout of the reticulation network. In the first lecture, when I spoke about sewer reticulation design, and in that set of notes also, you'll see that you do have a layout. You will also have to do something similar in your assignment, which I will give to you next week. So you will need information about this together, but as you see the layout plan, that's not enough in terms of the construction and in terms of design. Right? There's not enough information on the layout plan. It's just giving you a plan overview of where your pipes are. From the design point of view, you actually need what we refer to as long sections, and this is the most important drawing that you would issue in your design. Right? So this is a drawing that's issued to a contractor. It's called the long section of the drawing, and it goes hand in hand with your layout plan. In your layout plan, you'll notice that those manholes, those donuts that you see, those black dots that you see on the drawing, those are manholes, and they're all numbered. And in the long section drawing, that's where the details are provided. Details for construction and details of the design also are contained in this particular drawing. And I'll go through this with you also. It's also a drawing that you would have to do for your assignment. So it's something that you would need to know. You need to know how to do it. Then and so, and in essence, and this will basically sum up this whole section or close up and round up this section on sewer reticulation design. Right. So let's get back to uh, the manhole drawing that we're looking at. Now, okay, first let me just, what I'll do is I first want to talk about the layout drawing. Just to give you an idea of how large these networks can be. This was the drawing that you're seeing now. I've zoomed out. This was a township in Pietermaritzburg. A few years back. I was involved in this project also, so that's how I have some information about it. And what you're seeing in this drawing is just the sewer reticulation. There was also water reticulation, and there was a road design and things like that. They typically all come together in a design project. You'll also have water reticulation, and you'll also have road design, and you'll have to work together as a team. Uh, you may be the person involved in designing all three, or sometimes you may be just designing one part of it. So you got to coordinate the services. So you got to coordinate and see that there's no clashes in the network and things like that. Now, uh, in this particular network or this particular township, there were already existing shacks that existed there, and the town planner had uh, designed the layout of it to try and accommodate try and save as many dwellings as possible, so that they didn't have to demolish too many dwellings. Uh, but unfortunately, after the plots were demarcated and the agreement was reached that, for example, certain buildings would be saved and certain buildings would have to be broken down, people still carried on building. So that's why you'll find in places dwellings that go across the boundary lines, or you might see a pipe going under a dwelling. It's not they're going to build it like that. It's that uh, people have built these buildings after the agreement was made. So, for example, on the screen where you see my cursor now, you see the sewer pipe going under buildings like that, what I circled in blue. So those buildings would need to be demolished. You cannot have a pipe under a building like that. Okay, what I want to explain to you in this particular drawing, if you look at it, you'll notice the first thing is that it's gravity flow. So every single line over here will be flowing downhill, or every what we call a run. Right? So every run would be downhill. So it will be moving from a high point to a low point because you have gravity flow in these reticulation networks. The second thing is you'll observe that you have pipelines and you have manholes. Right? Now, the manholes are provided for certain reasons and at certain positions, and it will become clearer just now. The manholes are numbered. So, for example, if you look at what I circle now, that's manual 125, and you see the manual 126 and manual 127. Now, each one would have a unique number. You cannot have duplication of numbers in these layouts. So every single manual has a unique number, and the reason behind it is simple. We're going to be drawing long sections, so we need to know when we look at the particular manual number, we know exactly where it is, and there's no confusion. If we had duplication of numbers, then we wouldn't know which one we're referring to. So each one has a unique number. You'll also notice that uh, just looking at these particular uh, pipelines up here, I just want something to bring to your attention here. You'll notice that the one pipeline started, for example, manual 125, that started with a manual, that pipeline, but the one below it, 116, it doesn't have the symbol MH, it has RE. That stands for rodding eye. And I'll also explain to you what's that rodding eye for. Right. So there's something to note, but it's not commonly used in our reticulation networks or rodding eye over there. Then you'll also notice that in your set of notes, the first lecture when I discussed about where you would provide manholes, you'll see the application there. You'll notice immediately where you have a change in direction. So that's one of the places where you would provide a manhole. So you can see it immediately. You've got a change in direction. I've circled that in blue now. Let me just delete that off. So there's no so you see at manual 118, there's a change in direction. At manual 119 again, there's a change in direction. So that's one place where you would provide these manholes. The second place where you would provide the manholes, you notice, for example, take manhole 126. Now, there's no change in direction at that point, but there's a manhole provided, and that's to do with the maximum distance that you can have between manholes. In a sewer reticulation network, it's essential in our design. We consider the fact that these pipes will become blocked in time, and the municipality will have to come out to clean them. And the way they clean them is they use what we refer to as rods, and they rod the pipe out. The rod is typically a steel bar that has threaded ends, and so they can thread the one into another. So they have a whole stack of them, and that's how they can achieve the length of it. So by keeping on threading on additional, for example, 1.5 or 2 meter lengths of rods, they can achieve maybe 60 meters in length or 70 meters in length like that. Right? So they bring it on the back of a truck or the back of a van. These rods all stacked up in a container. They screw them together and then it forms a long a rod like that. At the head of the rod, there'll be a cone. Let me just take out my sheet. So uh, they have these rods like that. And then they just join the rods will screw into each other like that, and then so there's another rod like that, and then another rod like that, and another. And at the end of it, they screw on a cone-shaped solid steel cone like that, and they're able to push from the end of one end. They push these rods, and if there's a blockage in the pipe, so for example, if you got a blockage in the pipe like that, if there's some blockage there in the pipe, then the cone will uh, push that or spread it out, and then it'll then open up the flow like that. Now, as you can see in the preferred position for coning would always be from the clean side of the pipe, or the part of the pipe that's not blocked. The backup would be on the upstream side of the pipe like that. The water would all be backed up like that. And once they just release that plug that's blocking that pipe, it will automatically self-cleanse itself and open itself up. Right? So, but there's a limitation on this length that they can actually rod. Now, different municipalities have different requirements. Some municipalities will specify 60 meters, some will go 80 meters. The odd municipality might say 100 meters, but for 100 meters, they would need power equipment. Even those rods to insert them 100 meters, they would require some sort of powered rodding equipment. So usually 60 meters is safe. Some municipalities may be prepared to go up to 80 meters in those for that rodding. So that's what would determine. So now have I lost that drawing? Sorry. Yeah. So that would determine why this manhole 126 was put in there. So that distance, the maximum distance, for example, in this particular one, if it was, for example, agreed that the maximum distance is 70 meters for rodding, that may be a limitation from the municipality. So that's when you then need to insert a manhole there. So if they need to clean the pipe, if they had a blockage for something at that point, then they can access it, the pipeline from manhole 126 and remove the blockage like that by rodding it out. And so that's the second reason why we would have manholes on these layouts like that. That's so the first was we said for change in direction, and the next one was we said for the maximum rodding distance or the maximum cleaning distance for the pipeline. Then you'll also notice if you look, for example, manual 20 and manual 21, like that at that point over there, that's a, so let me just trying to zoom in here, just to, trying to, I'm trying to, this thing pan this drawing. Okay, there's, I can do it like that. Okay, coming back to this manual 120 and 121, why are they inserted in that position? Because you already have a manual 124A that's close by. So why was that manual inserted in there? That's to do with a change. Sorry, excuse me a minute. Excuse me, they've got some monkeys behind me making a noise. I just need to chase them. Just give me half a minute. I'll come back now. Okay, my apologies for that. Okay, I was talking about the reason for manuals 120 and 121. Uh, you also need to provide a manual where you have a change in the depth of that run of pipeline, where sometimes you got to make the pipeline deeper. Now, if you notice the pipelines, for example, from manual 123A to 124A to 120, those were all in residential areas of two plots. And then we suddenly came across a road. The pipeline has to cross a road. Now, the cover requirements beneath a road is more than over your stands or plots. So we would then need to deepen the manhole. So we then got to go to a deeper level, and that's why that manhole 120 was provided at that point, manhole 120 and 121. And then after manhole 21, the pipeline can get shallower again. So that's the reason behind it. Now you'll see that happening uh, in the long sections of these the long section drawings. So just bear with me. Right, so we've got these manholes here, and okay, I explained to you about why we would have manhole 121 and 120. That because at that point we then need to make those. We have a road crossing, and you see these in the long section. So now you start understanding why you need long sections. So how much deeper it's going to get. What will be the depth of these manholes at each of these points? How much of ground cover do you have? Do you have enough cover to these pipes? You will only see all this detail in the long section drawings. And just to give you a preview of that, for example, it's in these kinds of drawings that you see that like that. And I'm just trying to show you of where the case of where you have where you want to change the depth of the manhole. Okay, I don't see it in any of these particular long sections, but you'll see it coming out in those particular kind of drawings there, where you have that change in depth. But, also, something to highlight, I mentioned about we provide a manual where we have a change in direction. Now, one of the things about in a sewer reticulation line, where you change in direction, you cannot have a bend that's larger than 90 degrees. But it always has to be less than 90 degrees. If you do have a bend more than 90 degrees, then you would need some justification for that, or the municipality would maybe provide an exception for that particular line, because usually you could easily get a blockage in a line where you have a bend of more than 90 degrees. So, for example, if you take manhole 127 that I've just circled now, that angle there, you can see it's a very small angle. When you talk of a bend angle, from the upstream pipe, if you have to extend it like that straight, and then the new pipeline that you're bending, so that's the angle that you're talking, and that angle there should not exceed more than 90 degrees. So the manual that I've circled now, let me just delete the other one so you'll see it's easier for you to follow. So the manual that I've circled now, you can see that that angle is less than 90 degrees. There are some manholes in this drawing, if you studied in detail, where the change in direction is more than 90 degrees, and that was just out of circumstances. But usually, as far as possible, you would avoid change of angles of more than 90 degrees. So, for example, uh, this kind of situation that we have here for manual 244, where it appears it's slightly more than 90 degrees that bend there, the change in direction, that's not the ideal situation, but it was very slightly more than 94. So from that point of view, that's why it was done, but it's not the norm to do that. Now, the details for this man, how do we accomplish all this? That's where, if you look at the standard drawing, you'll see that these are the standard drawings. Now, in the middle of the page, you see those circles. That means that these are ring manuals, the concrete rings that they're being constructed. Uh, they standard, you just buy them precast, these precast rings, so that's why they've been used there. They don't have to be circular in shape. You can build these manuals with brickwork also, and then usually you'll have a square or a rectangular manual if they would brickwork. Now, let me just go into this to show you how we accomplish what I've spoken about earlier in that drawing. The first one, looking at this, yeah, let me just explain this to you. Uh, the first drawing on the left-hand side, this is just a pipeline that's taking a bend in the manhole, and it's a 90-degree bend. So you can see the pipeline comes in. The pipeline enters the manhole, and it stops at that point over there where I've circled. Right? And same thing, the pipeline that's exiting starts at that point in the manhole. What's happening in between here, uh, that's what we call benching. So that's not a pipe over there. That's like a channel that's formed with the concrete, and let me just show you that also. Uh, let's get this one need to go down on this drawing now. I don't know why my this thing is troubling. The typical of what happens inside the manhole. just to show you the details, the construction details of what we do in the manual. You see the pipe entering. So, for example, on the bottom left-hand side of your screen, if you look at the section here where my cursor is circling at the moment, that's the pipe that enters, and that's what I mentioned to you. The pipe is stopped off at that point over there. So this is the manhole. We provide a base to the manhole at the bottom. That's in concrete normally. So you have the base, and then these manhole rings are then placed on that base over there, and there's a cutting so that these pipes can enter at that point over there into the manhole. So the pipe stops at that point that you see, and the pipe that's exiting the manhole also, you notice is at that point over there. So between the two pipes, uh, what's done is they fill in a kind of like a concrete mix or cement mix, which we refer to as benching, and they then will form a channel like that. So you can see this top line here, that's a channel that's being formed in this manhole. And you see that detail in the bottom right-hand side corner. You see more details of that. So what I'm now showing you with the blue line, this is what we call the benching that you can see with the concrete or that screed or that cement paste. This is what they formed inside like that. So they formed this channel over there. There's no top over there. The circle that you're seeing over there, that's these pipes that are either entering the manhole or exiting the manhole in the background. So between the two pipes, you have what's I've drawn in blue. That's the shape over there. That's the benching over there. So any water, anything, for example, that falls would roll down the slope and fall into that channel like that, and then it'll flow out of the manhole over there. Right. So this is the kind of detail that you provide inside a manhole. So this is what's happening when you have a 90-degree bend. These are typical details just to show you. So that's the kind of detail that you have like that. Now, this bend, like I mentioned, would not be more than 90 degrees because then you would achieve, in terms of flow, there would be a big loss in the flow if you try to have larger than a 90-degree bend. You're now like trying to go against the flow direction if it's more than 90 degrees. The next manual that you see, what that I'm circling now, this is for where you have an angle, a change in direction of less than 90 degrees. Also shown to you in this particular one is where the pipe size changes. Just out of interest in this particular detail, it seems that we're going from a larger pipe, right, from a 150 to a 100 diameter pipe. In practice, we never ever do that. We would never go from a larger pipe to a smaller pipe. It will always be from a smaller pipe to a larger pipe. Yeah, but this is just showing the idea. What I wanted to show you is where you have an angle less than 90 degrees. So that's pretty straightforward, nothing complicated to that. The next manual you're seeing, this is an intersection that you see. And this is how we detail an intersection. And again, it's something that's important for you. You have a pipe that's passing through. So, for example, we have our main pipeline like that goes in that direction. I haven't drawn that line straight, but that's what you have. So you have the pipe that goes now. It would enter the manhole and then through the benching. So it would the pipe would terminate at that point over there. So you have the pipe like that, a run that's going through like that, and we then have an intersecting pipe that comes through. Now you'll notice that we never ever detail it where we have this 90-degree intersection like that. If I may just go to a blank sheet like this and just to so delete all this and show you, just to explain to you something about this with the sewer reticulation lines. Uh, we never ever have an intersection that would look like that. In water reticulation, yes, you have an intersection like that, a section like that, but in sewer reticulation, we don't ever have where we have flow in that direction like that and flow coming in like that over there with this 90-degree like that. We don't ever detail it. And the reason behind it is simple. You have gravity flow over here. If this pipe is running flow, the main pipe, then you will not be able to drain this pipe, or it will drain very, very slow, and you will then, this pipe will in effect be like a blocked pipe. Uh, it's common, for example, when in stormwater reticulation, if this error is committed, you find that in a heavy rain, then the town, whatever, some of the manholes and things, they remain flooded and they're not draining out. And it's because of this kind of situation where you have these kinds of 90-degree bends. Right? So that's why in a sewer reticulation line, when we have an intersecting pipe, you'll see it's done like this. So the flow is coming like that down this pipeline, and then it's turned already partially in the direction of flow. So the main pipeline is flowing in that direction like that, the main flow in that. So you have there, and that's your collector line that's flowing in that direction. So you can see that through the benching, we achieving a kind of a bend like this, and we then changing the direction of flow like that. So by the time it enters the collector pipeline, we've already um, uh, given it a component of velocity in the direction of flow in the collector pipeline like that. Right, so you can see that bend. So it's always in a sewer pipe or a stormwater pipe. Uh, this is the kind of detail that we would have in the manhole. Right? And this is achieved through this benching that we can shape the way we want the flow to occur in the manhole by the use of that benching like that. Right, so this is a typical intersection detail where we have one pipe intersecting into the collector pipeline like that. Uh, you can also have two pipelines meeting intersecting at one point intersecting a collector pipeline. It's possible. Right? So you could have two pipes that would join into the collector pipeline, and that's where you see in those next two drawings. Now, if you got I'm going to skip to the middle on the right-hand side of the drawing, and I'll come back to the one to the left of it just now. If you got two 90-degree pipelines, for example, coming into your manhole, and again coming back to this blank drawing, as you can imagine, we would never ever uh, in a sewer reticulation have a kind of intersection that would look like that. Right? We just simply do not do that because you will not achieve if the pipes are running full, then the lateral pipe will not drain easily into the collector pipe like that. So we would never ever have an intersection like that. We saw that we then have to have an intersection where if we had one pipeline, so we then sort of gradually turn it like that. We have that kind of intersection like that. Uh, so that would, and through the benching, would achieve that. If you have another pipe, when to have a second pipe intersecting, then we would need to again divert it like that, provide something, a pipeline like that, that comes with that. You can change the direction of flow into the collector pipe like that. So that's what's happening in the next detail. So that's what you're seeing in this drawing. On the right hand side, you have the two pipes that are coming in. The one is slightly offset from the other. That's not a problem, but you can see we have our main collector pipeline running in that direction like that. So that's the direction of the main collector pipeline. And then we have a first pipe that's coming, and that's going to flow in that direction, and then a second pipe that's coming like that, and that direction is also turned like that using the benching within the manhole like that. Right. So that's uh, in terms of, so you can have a maximum of maybe two pipelines joining into one collector inside one manhole. More than that would probably not be practical from a construction point of view. So that's why you don't see any details here. Uh, then you see this kind of intersection, for example, where we have they're not coming in at 90 degrees, but you also have two pipelines joining into a particular manhole. So you got flow, for example, coming in like that in that direction, and flow in that direction, and then going out. So in effect, what you have here is a bend, and at the bend you have a pipe connecting up like that in this particular pipe here, and what's referred to as a terminal junction. So this particular drawing, this is what it is giving you an idea of how we actually achieve uh, the change in direction, or how we have two intersections, or one pipe intersecting, as one sewer pipe intersecting another sewer pipe. Right, and it's all that is possible because of this benching detail that we have at the bottom of the menu. Now, on the top of this drawing, you may be wondering, okay, well, what's going on in this, or what are we seeing here? What's going on in all of those details there? So let me explain that to you. We now have the manhole, and what's drawn here is half of the manhole, and maybe even less than half in terms of the height of it. So uh, what is this showing is the pipe. So these very pipes that you're seeing here, whether it's the bend or whichever pipe or the intersection, how it would enter into the particular manhole. Now, what you're seeing here in the top left hand now is where we need to change. the level or the of the pipe. So in others, we're stepping down the pipe. We want to make it deeper. Okay, let me go back to my drawing here and just to explain to you what those drawings are all about over there, just to give you some background to that. If you have, for example, that's your ground level roughly like that over there. And for let's say you're going to cut a road platform at this point, for example, you're going to cut out a road platform, something like that, on your like that. So that will be so you'll then have a road at this point like that, and you have a sewer pipe that's running like that. So the sewer pipe would come happily along like this, and you may have, so for example, that's your sewer pipe like that, that's coming along like that, and you'll have cover over there of maybe 600 millimeter or 800 millimeter cover like that. So let's say we had 800 millimeter cover at that point like that. And we're now coming under a road. And under a road, you need at least 1.4 meter of cover to prevent damage of the pipe. So this pipeline cannot continue like that under there, because then you won't have enough cover under the road when it's built like that. So we need to deepen the pipeline at that point. And the way that's done is to provide a manhole at that point. So we would then provide a manhole like that. Put in a manhole like that. So the pipe would flow in at one point like that, and then it would flow under the road like that at a deeper level at that point over there. And we don't want it to continue at that same slope. For example, the slope might be different the way it was overland, and we may or may not provide a manhole at that point further down over there. So there we might want to actually lessen the slope, change the direction of the slope. So that's the reason why we might provide a manhole at that point. But you can see now you've got flow in that direction, and you then have to uh, change or step the flow down. It needs to go down the manhole and enter the pipe at that point. Right? So you have this step uh, in the flow in that particular manhole. So that's what these details are about that you're seeing in this particular one. That's so you have the pipeline coming like that. And there you see it going down to provide the step in the flow like that, and it comes like that over there. Now, what's this? So, if that's how the flow occurs, what's this region that I've circled over here? Why is that provided like that over there? Uh, it's simple. The reason that you have this on the top that it's shown, it's not so that the flow would come here like that and fall down like that. Right? That's not the purpose behind it. It would flow down. It would first encounter this bend and go down. And the flow would go down that pipeline. The reason why we have this small section on the top is simply for rodding. That if the pipeline were to be blocked at some point, then we can get access to it and we can then rod it and rod it clean. So, for example, just so if I may show you, let's for argument's sake that there was a blockage in the pipeline at some distance down the pipeline there, and we needed to rod this pipe. Uh, the workman would come into the manhole over here at this point. And they would insert rods. So they would insert, those rods are flexible. They'd insert the rod like that, and it would have a cone end like that, and they can push it, and they could then release that plug from there, and then the water would then flow down and come down like that over there. So that's the purpose behind the top section of the pipe that you see there. It's simply to provide access to the pipe so you could rod it easy. Similarly, if they were rodding the pipeline, if, for example, uh, if they were pushing the rods down, a rod would come straight like that. A rod would not easily bend down in that shape like that. So it would need to provide it so that it's actually they can pull it through like that into the other manhole like that, and they can see it emerging at that point over there. So that's for now you get different kind of steps uh, in this manual. So this is for between half a meter and 1 meter step. So that's telling you that that step over there, that step over there in the pipeline is between half a meter and 1 meter. Like that. Now this typically would happen where you have a road crossing where you then got to make the pipeline deeper. If you have deeper manholes than that, for drops between uh, wait, I'm just trying to see the detail behind it. Uh, so you'll notice that they for different depths. I think there's something not right in what's written here because this is the same showing you between 500 and 1,000. I think that the left hand was for drops less than 500, I don't think that word between was supposed to be there. There seems to be some error in this drawing. So this is between 500 and a meter if you have that kind of step. And this is, as you can see, you would never get gravity flow upwards. So this will confirm with you that the whole purpose of this is simply just to insert the rod to clean the pipeline. So that's why you have it like that. And then if you got a deep manhole where the drop is more than a meter, you can see these kind of details. And again, a very deep manhole, similar kind of thing that so you have. So this is where you have a step in the pipe. So here you have a pipeline coming along at that point, and you have a very deep step where you're going down, and it's going to flow out from that direction like that over there. That's hopefully that gives you some idea of you may not be aware of it. You're totally new, and we don't normally look down manuals, so you wouldn't really be familiar with it. So that's why I've this provided you with some details for this. It also, without knowing these details, you wouldn't really know what to do in a sewer reticulation design in the layout plan because it affects the way you would determine the layout plan. In practice, without knowing what you do at the manuals, you cannot do a layout plan. Right, so this is one aspect of it. So the manual details that we provide, and that's the layout plan that I've spoken about. I've spoken to you about you cannot have a direction change of more than 90 degrees. So now you understand it, and you can see that happening over here. You can see, for example, a manhole here where you got two intersections. So you have a manhole and you got two laterals joining in, and that's your collector going out like that over there. You can also see, for example, if you take the manual that I've circled now, you have one collector pipe, and then you have a lateral joining in at that point. Uh, Here you also have the manual 228. You see that two pipes joining in, but they're not coming in at 90 degrees to the collector pipe. You see they're at different angles like that. And all those details, you've seen that in those particular drawings. The next aspect that I want to discuss with you is what's referred to as a long section, a very important component in a sewer reticulation line like that. Well, now, um, again, just to stress with you something before I actually get to the details, I first want to just show you one aspect of layout, what the kind of information that you see in a long section drawing. So the what you're seeing now, the drawing in the middle of the screen, the top line where my cursor is running, that's the ground profile. That's the ground level like that, and you can see quite uh, not smooth at all. It's all jagged. There's a jagged line. You would the line below that, those two parallel lines that you see, that's the actual pipeline that's represented by those lines over there. And you can see that the ground is the fall of the ground is not the same all the time. So the average, the slope is changing. You got one slope there, and then you can see like another slope like that. So the pipe grade line has also changed to match that over there. Right. Then you'll notice over here that on the right-hand side, you have, for example, what looks like a donga or something, or a channel, maybe a stormwater channel or something that's catching that stormwater flow there. And you now have very little cover to the pipeline at that particular point. So this you would only pick up in these long sections like that. So when you see this, you now know you've got to provide some protection to that pipeline, or you go maybe got to do some detailing will have to be done over there. And you can see in the notes in this particular drawing, there's a note there. Cover protection to be determined by the engineer on site. So this pipe at that particular point has no cover, so something would have to be done about that. So we'll have to maybe cast a concrete slab or something over it to protect that pipe over there. Right. But the important thing what I want to show is that it's not always from the start to the bottom, one straight line, the ground. The ground line varies, and we then have to design accordingly to that. That it's the ground line that, in essence, dictates our design or our in these things. Okay, now uh, to explain to you these long section drawings, now the first thing to observe, let me just, I'm going to now, I'll use this first one over here. you'll notice that you have these rows over here, and there's information typed in each of the row. You'll also notice there's verticals coming up on these rows over here. And what you'll notice is that at every manhole you have a vertical line. So wherever you have a manhole, we then drop these vertical lines like that, and we then provide information like that. So this information, because it's at a manhole, so it's going to give you information about that manhole, right? So at every manhole, we drop the vertical. Uh, and then between the manholes, we have the pipeline that I've drawn there. So that's what I've circled now in blue. That's your pipeline between manholes. The manholes, we've drawn them in solid, so they stand out. The manhole is numbered. Every number that you see here coincides with the manhole on number on the plan. So if we go back to this layout drawing over here that we had a manhole number like that. So for every one of these manholes, the number that you see on the plan, that would be the number that you're seeing in this long section over there. Right, so that's the number you're seeing over there. So this is from manhole 189 to manhole 190 like that. Now, an important aspect of this drawing, you'll notice we have a vertical scale, we have a datum line. So this would be to suit the particular drawing. So that line over here, that's the 672 meter level. And then you see that 73, 74, 75, 76, that's 673, 674, 675. Right, so these are the levels. And just for the sake of making it easier to read, we've left out the 600 in front of each one. And again, that's typical of the way these details are done. Then you notice in the rows over here, in these rows, there's one row that's called the chainage over here. Now, the chainage starts off at 0, and you see it increasing as you go along. This is the distance. This is the planned distance along that sewer pipeline. So this is giving you your horizontal scale on this particular, if you think of it as a drawing. That's the horizontal scale. Now, notice we're starting off from 0 meters and we're going to 105 meters over there. Right? Whereas, notice the vertical scale, right? Over that same length of it. So we went 105 meters. About this, in this drawing here, that's about what? About 6, 7, 8 meters vertically. So immediately that tells you that the vertical scale and the horizontal scale is not the same in these drawings. Right? The vertical scale is much larger than the horizontal scale. And the reason behind it, if you were to draw the vertical scale the same as the horizontal scale, you would not see the details. It would be this drawing won't be legible. Everything would be, for example, would happen in that one line. So you wouldn't really see the ground profile. You wouldn't see all this change in levels in this pipelines, like that, the change in slope of these pipelines and things. So that's the reason why we have this a different scale vertically. Typically, the vertical scale will be between either 5 or 10 times the horizontal scale that for this particular drawing. So I'm just going to show you something. If you look at this particular drawing here, somewhere there'll be some information about the scale of the drawing. Just trying to find that information. Okay, it's not given on this particular drawing here. Uh, okay, there's it over here. You can see the scale of the drawing was given there in that bottom part of the drawing. And there you can see in this particular one, it's 10 times, right? Let's go back here. So the horizontal scale was 1:1,000, and the vertical scale is 1:100. And so you can see there's a 10-time difference between that. And so that's the important thing in these particular drawings. Uh, sorry, I'm just going to get back my whole thing here. Right, okay, I'm just trying to page back there. Uh, right, so we have, there's a difference between the vertical and the horizontal scale, and that's what we have over there. Then I explained to you that the top line, that's the ground line. So that's your ground line. So that's the ground line. The next two set of lines, that's your pipes that we show you in these drawings. And the colored in vertical lines, that's your manholes that we show. And every manhole is also numbered and should have the same number as you have in the plan. Then coming back to the rows of information that we have. The first one, now it doesn't have to be in this particular order. Different consultancies or different software programs may rearrange this and have it in a different order. Some of them might have chainage as the first row. Some of them might have ground level as the first row. It doesn't really matter. So let's look at it and I'll explain it to you in a more logical sequence than what's written there. So the first line that we have here is the ground line over here. So you can see the ground line. That was the ground line that we had there. So at each manhole, the ground level is given. So you can see what I'm circling now over here. So that would be the ground level at the top of each manhole at that point over there. Now I'm going to delete all the other things so you won't have this clutter. So that's one row in this particular long section drawing over here. Right. Now, you would get this information from your survey drawing or from your layout plan. You would be able to read what the ground level is at the top of those manholes. Uh, the next bit of information that you would require to provide the next row uh, would be the invert level of the pipeline. Right, so you can see the next that row over there. So let me delete the ground levels over here now. So the invert levels of that at each manhole. Now, what is the invert level? What are we talking about when we refer to the invert level? Let me come back and explain that to you. Uh, the invert level is simply, okay, I just want to delete some of this, remove the clutter so it's easy for you to see. Uh, the invert level would be, let me just enlarge this. The level at this point in the manual. So that point over there, I'm trying to draw, oh, my pen is too thick, sorry. I can do better than that. Let me just change my pen thickness size. Okay, that will be better. At that point. So that you can see that's what we refer to as the invert level of the manhole. It's that particular level. So this with the benching, we formed this channel. So it's in other words, it's the lowest point where the flow occurs, right, in the pipeline. So that's what the invert level is of the manhole. And that's a very important bit of information that we would need to provide in that long section drawing over there. And that's provided, you see there's a row there, and for every manhole, we provide that information. This, again, to elaborate to you what we mean by uh, invert levels, just to clarify that, some terminology again, I just want to, it's the scale of this drawing because I'm zoomed in, so that's why it's giving me that thick line there, right? So if I have a pipeline, yeah, that's much better now. If that's my pipeline, that and it's not very circular, but I'm just illustrating something to you. If that's the pipeline and you have your center line like that, so now okay, this one is quite bad. So let me, if that's the center line of your pipeline, and you have a pipe, for example, sure, again, I'm battling to draw with the mouse here, so just bear with me. Uh, okay, maybe that looks a little bit, okay, okay. Uh, no, it's terrible. Excuse me, it's something to do with the table and the mouse that I have here. Let me try again, one more attempt. Okay, now I did it slow and I'm rushing. I can't get it right. So you have the pipeline, the wall thickness of your pipeline, and that's so I just have to draw it slowly, then I get it a little bit better. So that's your a pipe that you have over there. Then the lowest point where you get flow in the pipeline. So that's that point over there. That's the lowest point that we get flow in the pipeline over there. That's what we call the invert of a pipeline. Right? So that's the invert of a pipeline for that. And in a manual, it would be the lowest point in the channel in the manual. Right, so that's the invert. And this particular point on the pipe, that the topmost point on the inside there, that where the water can make contact with the surface on the inside of the pipeline over there, that particular point over there, that's called the crown of the pipeline. That's what we refer to as the crown of the pipeline. Right, so some terminology that you'll come across occasionally in the profession, crown occasionally, but invert, very common, an essential term that you need to know in the pipeline. So in this long section drawing that I spoke about, the invert levels at each manhole for that pipeline are given there, and you can see it. And again, notice when I spoke to about the ground level and this invert level, it's only where we have a manhole. We do not provide information like what we do on a road drawing. It's a common mistake that many students make is that they would then provide information, for example, at every 20-meter intervals like that. They would drop a vertical at every 20 meters. That you do for roads, long sections. You never do that for sewer long sections. Right? For the sewer long sections, it's only at the manholes that you provide this information over here. So like you see over here. And so I've spoken to you about the ground levels at each manhole. Now the invert level, so that tells you where the invert level of the manhole, and that would give you the invert level for those pipes also, that they would coincide. Then once you know that those two bits of information, the depth of the invert that's provided also in the drawing. So you see and the next row gives you the depth of the inverts. And the reason why this information is provided, because this tells you the cover, gives you an indication of the cover to the pipe. Right. Now, obviously, that's not the cover to the pipe, the depth to the invert. The cover to the pipe would be roughly this depth to invert minus about the size of your pipe. So if you had, for example, in this particular one, the pipe is a 160 millimeter pipe. So if you roughly minus about 160 from this from the depth to invert, that will roughly give you. And I'm saying rough because remember the invert is not to the outer part of the pipe, it's to the inside where the flow is. So if you minus a pipe diameter from there, roughly you'll have about the cover to the pipe, to the top of the pipe over there. And so it's about looking at about a meter cover that in this particular long section they were looking for. Right, so by looking at this depth to invert, you can then ensure that you have adequate cover to the pipe. So from a design point of view, that's important information for you. Right. The invert level, that's very important to the contractor uh, because the contractor would need to know how deep to dig those manholes and at what levels to lay those pipes. So the contractor would be very interested in the invert level of the pipe. Then you notice there's another row here that gives you the chainage. Uh, the chainage I mentioned was the horizontal distance as you're going along the pipe ladder. So you can see chainage north 24, 73.198 and 105.34. Let me just go back to the layout plan and let me explain that to you. So for example, let me just get rid of the other line so then you'll understand. It's easier to follow. Uh, if you were doing a long section, so for example, from manual 233 to this manual 226, if you were doing a long section like that, so it would be those three manholes, then the planned distance from manual 223 to 234. So for example, I'm just giving you an example. Let's say if that was 55 meters, like that, and let's say the next one was 45 meters, the distance from manual 234 to that manual 226, if that was 45 meters there, if you had that, then the change of manual 233 will be 0. That's you starting. So you always start at the highest manhole, right upstream. That would be the highest upstream point for this particular long section, manual 233. So that would be a chain is 0. Then the planned distance is 55. So I'm just writing, let me write it. So this manual 233 would be at chainage north. This manual 234 would be at chainage 55. That's because the distance between, so let me set the chainage 55 like that. That's 55 because the planned distance between that and that is 55. The length of the pipe would be slightly more than 55 meters because it's on a slope, right? Whatever the slope of the pipeline, so it'll be slightly, but we're giving the planned distance. Then the planned distance from manual 234 to manual 226 is 45 meters. So the chainage at manual 226 would now you'd have to add up the 55 plus the 45, so that will be 100 meters. So that will be changed 100 over there. Right, so you get an idea now. So it means how far in plan are you from the upstream manhole? from the most upstream manhole. That's what the chainage distance, that's what is given to you. Again, that information is extremely important to the contractor, and the contractor would need that information. It also provides you with let me come back to this. As a designer, it's information that you would require to calculate the slope of that pipeline. Right? So it's something that you would also be interested in as a designer. So that's the. So now let me come back here. Something's gone wrong here with this particular. No, so I've got the wrong drawing there. Yeah, that's the drawing we're looking at here, right? So so that's the next column that I spoke about. Of information that in your design you would need to provide is the chainage information. And again, that chainage is only provided at each manhole. Not in a road layout drawing, you normally provide the chainage at every 20-meter intervals. So I notice in a sewer reticulation it's different. We only do that at every manhole point. If the manhole is 5 meter apart, then you'll do it at that 5 meter. If the manhole is 50 meter apart, then you do it at 50 meter like that. So we've now covered those rows over here, and these give the details for construction. Uh, the next three rows that you have there, these are directly related to your design. Right? The next one you see is the pipe grade. Pipe grade is the word grade. Another word for it would be a synonym for it would be slope. So in essence, that's what it is. So what's the slope of the pipeline? And you'll notice that for each pipeline that we have in this particular long section, we have three pipelines. So one, two, and three. So there's three pipelines there that run between those manholes. And so three pipelines. So we have those three information about the slopes of those three pipelines. It's given both as a percentage. Right? So you see at the bottom there, percentage. The slope is given in the form of a percentage, and it's also given in the form of one in something like that. Uh, that's important to you because just by looking at this immediately at the first glance, you can see whether your pipe is steeper than the minimum grades in the CSR tables there. There's a table there where you have the minimum grade because then you know whether you're going to achieve your desired your minimum velocity or not. And so this information is important from that point of view. So you know how steep the pipeline is or how flat the pipeline is. How steep or flat also it would also inform you about the potential for blockages. So by looking at the pipe grades as a designer, you then know whether the pipeline is too flat or not. If it's flat, you can expect blockages. You can advise your client that they would need to budget for that, that from time to time they're going to get blockages or not. Right, so that's why this information is provided. The contractor also needs this information because to lay those pipes, let's go back here. This long section pipeline that's maybe 50 meters or 60 meters in plan, they would need to put pegs in the ground and they would need to know when they're digging the trench, the invert of the trench, they would have to follow a particular slope or grade line. So that's, again, vital information for your contractor to know this pipe grades. Then the next two columns, the second last column that you see, the pipe details, that's where we specify the size of the pipe. Notice we specify the material of the pipe. Right, so you can see that's a UPVC pipe. That's the size. Okay, let me just circle it again. The bits of information. An important row, the size of the pipe, the material that the pipe is made from, then you see the bedding details for the pipe are provided here also. Right. Now the bedding details, that's in the last lecture. I will cover that for you. Uh, Whether the pipe is flexible pipe or rigid pipe, you'll understand the details of that in more detail when I cover that relevant section. But it's very important information because it affects the durability and the strength of that particular pipeline to provide the appropriate bedding. So whether it's bedding for a flexible pipe or whether it's bedding for a rigid pipe, you would need to know that also. Right? So that's where we have this information. So it gives information to the contractor. So the contractor now knows what the size of pipe, what material of pipe, and what kind of bedding to provide around the pipe. Just to come back here to this drawing, let me just explain something to you about that. When we talk of the bedding of a pipeline, what are we referring to? Uh, if that's the ground, for example, like that, and you would have dug a trench like that for your pipeline, and you would have then laid the pipe like that over there. Right. Now, the pipe won't sit in the air like that. Obviously, they would have you would have maybe over excavated, and you would have had the then backfill like that. If you had over excavated, you would backfill. If you did not over excavate, then you just dig the trench to that level where you can lay the pipe, and then we provide a protected layer around the pipe. So this fill that we now fill back around the pipe, this is a selected fill, and this is what's called the backfill. And at the bottom here, this is referred to as the bedding of the pipeline. That's at the bottom part here. That's your pipe bedding. So that's the bedding, and that's the backfill material around the pipeline. Now, obviously, this backfill, uh, so actually backfill has to be. It must not. If you got a plastic pipe, you wouldn't want uh, the backfill to have stones with sharp corners, whatever, because then they may, in time, pierce through that pipe and cause holes in that pipeline. But I'll talk about that in the last lecture when I explain about rigid pipes and flexible pipes. Right, so coming back to that particular long section drawing, that's where we provide information. So you see, there's four things that are four bits of information in this particular row over here. Then the last one, the last row, this is where the design information. So in the tutorial that we had done in the last lecture that we had, we looked at the full bore flow, right? So the bottom one where we got the maximum. These are the for example, either full bore or the maximum. I did explain to you about that maximum at 0.8D in the diagram, so you'll understand that. So this is basically the full bore information for the pipe, and then it has not been provided in this drawing, but you should actually provide that information. The actual design, what's the design flow in the pipe, and what's the design velocity in the pipeline. So for the full bore velocities, we can see we have quite high velocities, 2.6, 3.6, 4.8. So we know we will then now provide some protection for the pipeline if the velocities are so high. As an engineer, you might decide to provide some sort of protection to the pipeline, or you might choose the appropriate material that can withstand those high velocities that we have there. Uh, so that's the velocity, and you can see the full bore flow in the pipeline, and we would then compare them to the actual flow that you have in the pipeline. That information is missing. Oh yeah, that's where you would provide it. In our last week's tutorial, not last week, the last time that we had a tutorial, I did explain to you how to calculate the actual flow and the actual velocity, and we would populate that over there. And so this is gives you information about a long section on a drawing. And basically, this sums up the section on sewer reticulation. Uh, this in all the information that I discussed with you today, you would need all of this information when you're doing your actual design and for your project also. I'll issue you a project by next week, Monday. You should have your project. I know I have told you earlier, I haven't had time to complete it. I'm still busy with the project brief, but by next week, Monday, I'm certain I will have it ready for you, and then I'll give you your project for that. And you would then need to make reference to this particular lecture so that the drawings that I've showed you today are all on Moodle, so you can download them or view them on Moodle, so you'd have some idea when you're doing your project for them. And so all of these drawings are on Moodle, and you can download them from there. Okay, so with that, that's the end of the section on sewer reticulation. Any queries from you, from your side? Any queries? Anybody? Anybody? Um, there was a query. I know I received an email from a student requesting to view their test one scripts. Uh, I will be on campus tomorrow. I've got a lecture from 10 o'clock to 12 o'clock for another subject that I lecture. So between 10 and 12, I won't be available. But if you come in, let's say between 12 and 1 o'clock tomorrow, or 12 and quarter to 1, actually, so between 12 and quarter to 1, you can come in and view if you want to have a look at your test one script. you're welcome to come and have a look at it then. Right. So just for those students that want to view their scripts, uh, providing you're allowed to come on campus, that's fine with me. If you can get access to campus and you can come there, you can come to the office there. So between 12 and quarter to 1, you can view it over there. I might be in earlier in the office, but I might not be available to show you your scripts at that point because I'll be uh, I have a meeting with another colleague of mine there, which I need to have some discussions with my colleague, and I also need to prepare set up for the lecture that I'm going to be having from 10 o'clock to 12 o'clock. So, uh, yeah, tomorrow between 12 and quarter to 1, you can come and have a look at your script, test 1 script. Okay, with that, I'll end this lecture. If you have any queries, you're welcome to ask. Let me just unshare the screen. I'll end the recording at this point. So